Welcome back to Mrs. Ogram's Maths. We are looking in this video at the Level 3 Maths and Stats paper from 2021, and it's standard 91585, which is the probability concepts paper. Right, question 1A, we have a bunch of information about some festival tickets, so pause to read. Okay, so we've got early bird, general, child, and not child. So the first bit of information we've got is that, where was it? So 1/5 of the tickets sold were early bird. So we've got early bird or general admission. So early bird was 1/5, making general admission at 4/5. And then we've got of the early bird tickets, 3/4 were adult. So adult, and the rest would be child. So that's 3/4, 1/4. For the general admission, 2/3 were adult. So adult 2/3, and child was 1/3. Festival organisers predicted 10% of the sales would be child early bird tickets. So that's this branch just here. So child and early bird, that would be 1/5 times 1/4. Oh, so yes, a quarter. So that's 1/20. That's not equal to 10%. So no, they weren't correct. Okay, next, calculate the overall proportion sold that were adult. So let's take a look at that. Would be adult tickets would be this one or this one. So general and adult, or early bird and adult. So probability of early bird and adult added to the probability of general and adult. So that'll be 1/5 times 3/4 plus 4/5 times 2/3. That comes to 41/60. Okay, now was it more likely for an adult ticket to be sold an early bird ticket or a general admission ticket? So we need to compare what's the probability of it being early bird if they are adult, and the probability of general. So general if they were adult. So the early bird, given that they were adult, we want early bird and adult over just the adults. So early bird and adult, that was this one just here. So that would be 3/20 divided by just adult. We worked that out just here. That's 41/60. That's 9/41. Now for the general and adult, we've got the one that we just worked out here. So that is 8/15 divided by the adult proportion, 41/60. That's 32/41. So now comparing these, it was more likely that an adult ticket was a general one than it was an early bird one. Okay, next question. Pause to read. Okay, so we start here with the original information that we had from 2021. Now, this question is not entirely straightforward to interpret, so just take your time working through this. So we've got that the new proportion from 2022, it's going to reduce the proportion of all the tickets purchased as general, so that's this bit here, to 1/2 of the original that they had in 2021 proportion. So this proportion here of 4/5 is going to be halved. So let's change that. Instead of 4/5, half of 4/5 would be 2/5, which would make this one be 3/5 for early bird. Okay, so now that we've fixed this is for 2022. Comment on the effect of this change on the proportion of adult tickets that are sold as early bird. Now that's the same that we just the same way of working out that we just did up here. So the early bird given that they were adult tickets. Okay, so let's go and work out that. So we start off with this branch, and oh, I've done it wrong already. So that's a 3/5 times 3/4 for early bird and adult. And we need to divide it by all of the adult possible tickets. So it would be early bird and adult, or it could be the general admission and adult that we've got here. So that would be 2/5 times 2/3. That comes to 27/43. And we need to make a comparison. It's probably easier if we do it in decimals. So that's 0.628 for 2022. Right, finally, we want to compare on the effect of the change. So we need to look at what happened before. So early bird and adult before was 9/41. So in 2021, this was 9/41. Which is 0.2195. So our new number is bigger than our old number, so it's increased the proportion of adult tickets that are early bird tickets. So let's start with this tree diagram again to work out what's going on. We want the overall proportion of tickets that would need to be sold as early bird. So we don't know this number here. So let's take that off. Let's call that a P, and this would be 1 minus P. So what proportion would need to happen so that the proportion of all child tickets that were sold that were early bird makes 30%. So the probability of early bird given that they're a child ticket has got to come to 0.3. Okay, so early bird and child, general and child is what we're looking for. So this probability here, so that would be equal to early bird and child divided by probability of child. So that should be in probability of. So this is that branch along here, P times 1.4. Oh, sorry, 1/4, not 1.4. And then all the children tickets is P times 1/4 for that top branch, and then add on the bottom branch of general child. So that'll be 1 minus P times 1/3, and we need to set that equal to 0.3. I'm going to put that into equation solver and solve ourselves a lot of time. Oh, sorry, save ourselves a lot of time. So into equation solver, we want F3, and I'm going to type that in. So putting it into equation solver up here, see if I can scroll that for you. Hold on, so you can see it. There we go. So you can see all the way through how I've typed that in. Like this, set it equal to 0.3, and then solve it, and we get that P is equal to 0.3636. Okay, on to question 2. We've got 3 different festivals, Idyll, Escapade, and Serendipity. We've got different performing groups, and these are the acts that are on offer at the different things. So this looks like we're going to be doing a Venn diagram. So we want to calculate the proportion of acts at Idyll that are unique to that festival. So let's see if we can set this up. We need 3 circles, 1 for each of the festivals. Okay, we'll run through the information that's up here. And actually, the most useful bit is the last one. And this happens fairly often on these sorts of questions. It's not the first bit of information that you can use straight away. That 3 acts at all 3 can go straight onto there. Right, 13, I'm going to also work backwards up the list and see what we can use. So 13 of the acts seen at Idyll also perform at Serendipity. So the total of overlap between Idyll and Serendipity will be 13. We've already got a 3 there, so what's left is a 10 here. 5 of the acts seen at Idyll also perform at Escapade. So the overlap between Idyll and Escapade is 5, so this one is a 2. And then Idyll offers 17 acts. So total in Idyll's circle, we've already got 15. So we must have a 2 just here. Then the question asks for the proportion of acts at Idle. So of all the Idle acts, how many are unique to just that festival? So that would be 2. So 2 out of the 17 that are on offer at Idle. Which 2 festivals have the greatest probability of people seeing the same acts? So Idle and Serendipity has a total of 15. Idle and what was the E1 escapade, I think, has a total of, so that's the overlap here. So we've got a 5, and then E and S is equal to 13. So we've got the most overlap between Idle and Serendipity. Now, just before I move on, because this question is asking about probability, I've just given numbers here. We really should express that as probabilities. So it'd be 15 out of 37 total acts, 5 out of 37 total, 13 out of 37, like that. Okay, part 3, a particular festival attendee can afford to attend only one festival. If they want to go to a festival that gives them the highest probability of seeing a unique act, so one that's not able to be seen at a different festival, which one should they go to? So that's a pretty easy one. Let's just go back and have a look and see who has, oh, actually it's not so easy. We've got to work out the leftover pieces. Let's finish off this Venn diagram. So at Idle we've got 17. Escapade is 14, and Serendipity is a total of 29. We've got a total of 37 altogether. We need to use that information to work out what's in these pieces here. Now, if we do the 37 minus the 17 that's in Idle, that makes 20. That must be in this area here. So that's got to make 20. Now, looking at the escapade number, that circle has to make 14, but we've already got 5 there. So this section in here would make 9. And then looking at the Serenity bubble, we've got 29 here, but there's 13 already taken care of. So this sort of bubble here makes a 16. Now, if we add together 9 and 16, that makes a total of 25, whereas we want the total to come to 20. So the difference between those two means we can pop a 5 in the middle here. So that the overlap means we'll have 5 counted within the 9 and the 16, and it'll take that total down to the 20. So now looking at the 9 bubble, if we've got 5 in there, then we will have 4 just here. And then the 16 bubble, if we've got 5 in there, we will have 11 just here. So that'll be 11 plus 5 plus 4 makes our 20. These two make the 9. These two make the 16. Okay, so tidying up, we get this one. Going back to the question we were on, which festival to go to if you want the most unique acts? Well, the highest number that's not shared with anything else is going to be this 11. Let's go back to that question. And since you always want to back up your answer with statistical reasoning, that often means trying to include some numbers if we can. So its proportion is 11 out of 37 of the acts are unique to Serendipity. For part B, we are comparing some predictions of which festival it was thought that somebody would attend and which festival they actually attended. Calculate the percentage of the predictions that were correct. So that means that the two things match. So this one, they were predicted Idle, they went to Idle. Predicted Escapade, they went there. Predicted Serendipity went there. So we have 80 plus 25 plus 5 out of the total, which was 214. And we've been asked to give it as a percentage. So let's do that. That'll be 51.4%. Okay, comment on the appropriateness of that model that was used for predicting. Support your answer with at least one additional calculation. So we need to use what we just did plus an additional one. So let's start with the one we just had. So it's only just a little bit over half correct of the total predictions. Let's see what it was like with each of the festivals. So we can look at the ones predicted to go to Idle, how many actually went to Idle, and then of Escapade and Serendipity. So I'm going to do that back down on the other page. So when we look at each festival individually, we can see that actually Idle was kind of carrying a lot of what we saw in that 51% previously. The other two were very poor predictors, especially the Serendipity. So overall, this is not a good predictor. Okay, Patrick owns a food caravan selling food and drinks at festivals. Pause and read the information here. So this question is asking us to think about if Patrick created a simulation, how it would help him to decide whether the pack that he got was likely or not. So we don't need to design the simulation itself, but talk about how he would use it to see whether the variation could be expected, that it is reasonable for him to have a pack that has only 85 cola drinks in it. So we start from the assumption that 1/3 of the drinks will be cola in this simulation. The simulation would then run and show us some possible distributions of how those flavors could end up with a sample of 300 drinks if the probability of each pick was 1/3 cola. Patrick can then compare within this simulation how many times he got a sample of 300 that had 85 cola or less, because if it got less, then that sort of adds towards the chances of this actually being a fairly likely thing. So then if that doesn't happen very often within the simulation, it gives a low likelihood of that particular situation happening, it could support his idea that the manufacturer's claim of 1/3 cola being in the mix, that it might not be accurate. And then finally, if the opposite's true, if we do see that there is some likelihood that this happens in the simulation, it will help Patrick to see the variation that's possible that could have produced a sample of 300 with only 85 colas in it. Okay, question 3. We've got festival tickets sold out online or through a ticket office. We're gathering data from the first 1,000 festival attendees to buy their tickets online. The data summarizes the age of them. So we've got less than 25, 25 and older, their main motivation to dance, socialize or other, and then we've got some numbers in there. We want to calculate the probability that the festival attendee is less than 25 years old and is mainly interested in socializing. So let's set ourselves up a table. So let's work through this information. First, we've got 750 of these attendees are less than 25. So 750 is going to go in here. The main motivation of 510 of these is to dance. So of those under 25, we've got 510 in dance. The remainder of the attendees are evenly split between socializing and other. So 750 minus 510, we've got 240 left. So that makes 120 in each of these categories. Now we've got 1,000 attendees in total, so this would be 250. For those older than 25, we've got, where's my mouse? There we go. 160 are mainly interested in socializing, so 160 in there. Of the remainder of the older attendees, 60% are interested in dancing. So 250 minus 160, we've got 90 left, and 60% of them is 54. So we have 54 in here, and 90 minus 54 gives us a 36 in here. So this will be 156, this will be 280, this will be 564. Okay, so this festival attendee chosen at random, we want the probability that they're less than 25, mainly interested in socializing. It's 120 out of the 1,000 attendees. That simplifies to 3 over 25. Okay, festival organisers claim it's at least twice as likely for younger participants to be mainly interested in dancing compared to older ones. So we want the probability that they came for dancing given that they are less than 25, so we can compare it to the probability they came for dancing if they were 25 or older. So dancing, given that they were 25, we've got, less than 25, 510 out of 750 under 25-year-olds. And then the over 25s is 54 wanted to dance out of the 250 in that category. Okay, now comparing. So 510 over 750 divided by 54 over 250, because the claim is that this will be at least twice as much. So let's pop that in. That comes to 3.15, which is more than twice as much, so the claim is correct. Okay, we've got two events that we want to see if they are independent. For independence, we know that we can times together two things and it makes the probability of them combined. So that's what we're going to check. So the probability that they are less than 25 and the probability that they came for dancing. So less than 25 is 750 out of 1,000. Came for dancing is 564 out of 1,000. Okay, so those two times together, and then we'll check it against the combined probability. So under 25 and dance. Under 25 is 510 and dance out of 1,000. That comes to 0.51, which is not equal to 0.423. Therefore, they're not independent. Part 2 is basically asking us to explain what it means by saying that they're not independent in this context. And it means the age that they are impacts their interest in the dancing, or that it varies according to which age group they are in. Okay, part D, give two reasons why we should take care of using this to predict that a new ticket buyer will be less than 25 and mainly interested in dancing. Now, this one, you need to go back to the beginning. We've done a bit of calculating beforehand. We need to look at how this was set up to see what might be the issues with using this to predict the next purchase. So go back to the beginning of the question. These festival tickets are sold online or at a ticket office, and this data is from the first 1,000 festival attendees to buy their tickets online. So those things are important. Let me just go back to this page here. So it's that it was the first 1,000 purchases and that it was only the online purchases. So here's the first one. It's only from the first 1,000 purchases. Subsequent purchases might have different reasons to attend. Maybe you get like the first people that book are really keen and enthusiastic. They've got a particular interest in dance, and maybe the others, the later ones, don't. We just don't know. So we don't know that they would follow the same pattern. Also, we should link it to both of the things. So I originally just said the different reasons for attend, because that was the dancing thing. But also, they've specifically stated about the age, so we'll put that as well. They could have differing ages. Perhaps the older people have more disposable income and they can buy those tickets early on, and the under 25s would wait until they've saved up or something. Okay, now the second reason was it being an online purchase, so let's put that in. So at the end of the question, make sure you've given two reasons. and that we've talked about the two things mentioned here of how it would impact on the age and the interest in the dancing.